Writing coordinate rules. So here's some things that we're going to cover in this video. What are coordinate rules? How do we write coordinate rules? And how do we use them to perform a transformation? So let's start off with what coordinate rules are. They describe what happens to the x and y coordinates of the pre-image when it's transformed into the image. For example, we might be told that the coordinates x, y are transformed into 3x, y plus 4. So that doesn't tell us what the original coordinates were, it just tells us what happened to them. So when we write coordinate rules, we're going to look at all of the x values and figure out how they change. And we're going to compare all of the y values and figure out how they changed. Typically, the x and y values will be changed in different ways, so we should look at them separately. Some things that you might look out for would be changes in sign. Did all of the x values become negative? So some things to look for would be changes in the sign. Did it become positive or negative? Adding and subtracting values. Did the same number get added and subtracted from each x or y value? And maybe the trickiest one is noticing when x and y switch places. Okay, so let's take a look at the coordinates we have right here. So I'm going to quickly jot down what A, B, and C are. And now I'm going to look at A prime, B prime, C prime. So let's take a look at our x values from A to A prime, etc. We might notice if I just look at A and A prime, the same number values are there. We have 3 and 5. But the 5 comes first in A prime, and the 3 becomes negative. So let's just check to see if the same thing happens in the other ones. If I look here at the B points, 1 moved to the first position just like 5. And the 4 became second, but now it's negative. And just to make sure we have the right information, check the third one. So that means our coordinate rule here, we always start off by writing x, y, arrow. So the first coordinate was the old y, and the second coordinate was the old x, but now negative. Let's try another one. I'm going to write out all 8 points, and then we'll compare. All right, I have all 8 points, both the pre-image and the image. Something I notice is that all of the y values look the same. But the x values, we go from -8 to +8. We go from -2 to +2, etc. So when I start off writing this, x, y, arrow. All right, so the x value changed signs. To show that it changed signs, I'm going to put a negative. Even though, you might need to jot this down so you remember it, even though all the numbers went from negative to positive, this right here tells us to switch the sign. Because when you multiply a number by -1, it switches the sign. And then the y didn't change, so we leave it, y. All right, so the next one, when we transform from rules, perform the given operation on each x value and y value, and then you'll just graph your new points. So think about it, what kind of rules will not make congruent figures? So you should be able to look at a rule and think, is that going to be a congruent figure or is it not going to be? So let's look at this one. I'm going to jot down the 4 points that we see here, and then we'll look at the transformation rule. So for each one of these, we're told to change the sign of x and leave y the same. So j prime becomes negative 3, 6. K prime becomes negative 1, 4, and so on. My next step is going to be to plot each one of these points. And let's see what kind of transformation we get. J prime is going to be up here. K prime is here. Just from those 2 points alone, you should be able to narrow it down on what kind of transformation we have. So this transformation has been a reflection over the y-axis because each point is the same distance from the y-axis from where it started. All right, let's look at one more. I'm going to take the same 4 points and I'm going to use the transformation rule shown above. So my points after the transformation, you'll see in the white lettering. Now I'm going to plot them. So let's start off. J, we go to 3/2, comma 3. So that's right around here. And then we're going to go to 1/2, comma 2. Here. 3/2, 1/2. A little off, sorry. And 5/2, 2. So that's a dilation. We haven't seen those in a few days. That's a dilation. So that might help you start recognizing when figures are going to be congruent or not. If the coordinates are multiplied, like we learned in dilations, when we multiply all the coordinates by the same number, we get a scale factor. So when you see those transformation rules, start looking out for dilations instead of making congruent figures. Okay, let's do actually one more quick example. I'm going to do this one a little less formally because you've already seen a couple of these. These are telling me to switch my x and y coordinates. So for j, instead of going over 3 up 6, I'm going to switch. I'm going to go over 6 up 3. And for k, I'm going to switch it. I'm going to make the point 4, 1. M started off at 5, 4, so we're going to go for 5. And L was at 3, 1, so it's going to be at 1, 3. I wonder if you know what transformation just happened. It looks kind of like a rotation, but actually what happened is it was reflected over y equals x. Which kind of makes sense here because the x value became the y value and the y value became the x value. So, for your summary, think about what a coordinate rule is, how they're written, and how you use them.